this is one of my favorite topics in microecon. It's a really interesting thing that we're doing here. What we're doing is we're talking about how consumers make decisions and what decisions they're going to come to. Putting that more concrete though, the actual goal here is to determine what combination of two goods, so we're determining what combination of two goods, X and Y, a consumer will choose to make themselves as happy as possible. Okay, so they want to make themselves as happy as possible, right? But kind of the catch to this is they want to make themselves as happy as they can, but what they choose has to be affordable. So it must be affordable. Now in this particular set of videos, we're going to be focusing on how to do this process of consumer optimization for consumers that have Cobb-Douglas preferences. And everything in this set of videos will be specific to Cobb-Douglas utility functions. Now, what I want to do next, and this particular video is going to focus on just the general process itself, whereas the second video is going to focus on an actual example. But what I want to do first, though, before we talk about the process, is kind of get a visual of what's going on in consumer optimization, because I think looking at it visually really helps to understand why we're going to do what we're going to do. So what we're trying to do is maximize utility. And remember, utility just means happiness. We're trying to make them as happy as possible, subject to their budget constraint. Which what that part means is that whatever we choose has to be affordable. Now, when we're looking at utility, this first part here, we know that since it's going to be Cobb-Douglas, I'll abbreviate that as CD, we know that the indifference curves that we're going to draw are going to be convex. Now, what we know about utility is that if they like both of the goods, they're going to get happier as they're moving this way, so as they move farther from the origin. So if this is U1, U2, and U3, U3 is going to be the best, U2 will be the second best, and U1 is going to be the worst of the three that are drawn here. And of course, there's still an infinite amount of indifference curves, but we'll just look at these three just to make it simpler. So we're trying to get on the highest indifference curve that we can, but we also know that we have a budget constraint, which will be linear and downward sloping. So something like this. This will be our budget constraint here. So what we're trying to do is find a point that has to be along this budget constraint line, but that's also on the highest of our set of indifference curves. So now what I want to do next is bring those two different ideas onto the same axes. Okay, so down here, we've got our three levels of utility and our budget constraint. And again, those utility curve or those indifference curves are going to be convex because we have Cobb-Douglas utility. Now, looking at this, what the consumer is going to choose as their optimal point, the best amount of X and Y, is going to end up being this point right here. So this is the point where the indifference curve is touching the budget constraint at just one point. That's this one right here. That's going to be our X star, which is our optimal amount of X, and our Y star, which is the optimal amount of Y. Now what I want to do though is compare this point here to points on our other two indifference curves to get an idea of why that's going to end up being the best point. Now if we compare to this lower one first, to U1, what we can see is that anything along here, this region that I'm shading right now, anything along here, they could have chosen this because anything along here would have been affordable for them. So why is it that they chose this point here instead of all of these points here? Well, the reason for that is that everything on U1 is going to be a lower indifference curve than U2. So everything on U1 is affordable, but they're less happy than they are at that optimal point. So that part's eliminated there. Everything below U2 is going to be eliminated because everything below U2, they're going to be less happy. Now, if we look at U3, what's going to be the problem with this one? Well, this one, they're obviously going to be happier, right? Because they're on a higher indifference curve. But we can see that at this point, they're further out than the budget constraint. So everything now is going to be unaffordable. So at U3, they're happier, but it's now unaffordable. Okay, so basically, to put it simply, the reason why that point where it's tangent right there, where it's hitting at just one point, is going to be the best point. The reason for that is that if we go any lower, then it's affordable, but they're less happy than they would be otherwise. And if we go any higher, then they're more happy than they would be before, but it's now unaffordable. Okay, so we know that anytime we have a Cobb-Douglas indifference curve, we're going to be looking for this point right here where the indifference curve touches the budget constraint at just one point. Now, with that being said, now that we can kind of see what's going on visually, what I want to do is talk about the actual step-by-step process that we're going to use to solve any time that we have a Cobb-Douglas utility function. Now, the first thing that we're going to want to do is to copy down our utility function and the budget constraint. And the reason why we're doing this is just to kind of get the ball rolling when we're solving. These are the two big formulas, the utility function and the budget constraint are the two big formulas that we'll be using as part of our solving process. So we want to just have those handy for later. And again, our budget constraint, the general formula for that is going to be px times x plus py times y equals m. Now the second thing that we're going to want to do is find the marginal rate of substitution, or your MRS. And so why are we going to do that? Well, the reason why we're going to do that is because in the next step, we're going to take our MRS and we're going to set it equal to the price ratio. And this step right here, conceptually, I'm going to put a star next to it because this step right here is going to be the most important part conceptually of this whole process. So now going back to our graph right here, remember what we said is the point they're going to choose is this one right here. And we said that we're going to choose that point because it's where our indifference curve is tangent to the budget constraint. Now this step right here, step 3, where we set the MRS equal to the price ratio, is ensuring that that's going to happen on the graph. So this step right here is known as our tangency condition, because what we're doing in this step is we're setting the slope of our indifference curve, our IDC, which the slope of our indifference curve is the MRS. We're setting the slope of our indifference curve equal to the slope of the budget constraint. The slope of the budget constraint is our price ratio, which is px over py. So we're setting those two slopes equal to each other. And if we set the slopes equal to each other, then we're finding the point where it's going to end up being tangent. So setting the slopes equal to each other leads to the point of tangency. And when we do this, it's going to ensure that they're as happy as possible. So it makes them as happy as possible. Okay, now once we've done step 3, we've already made sure that they're as happy as they can possibly be. So the goal from this point forward is to make sure that what they're going to choose is actually going to end up being affordable. So what we're going to do from here, or step 4, is we're prepping for the point where we're going to plug into the budget constraint. So before we can do that though, we need to isolate either x or y from the tangency condition. Now you can actually isolate either one. You could do x or y and you'll end up with the exact same final answer, but it's kind of just convention to isolate y, so that's what I'm going to write on here. We're going to isolate y from our tangency condition. Now once we've done that, again, the goal is to make sure that what we're choosing is affordable, so we're going to substitute the isolated y into the budget constraint. So we're taking the thing that's going to make sure that we're as happy as possible, which is that tangency condition, and we're subbing it into the thing that's going to make sure what we're choosing is affordable, which is the budget constraint. So we're going to do that. We're going to sub into the budget constraint, and we're going to simplify that. And what this step is going to lead us to once we've simplified is our x star as a function of px, py, and m. And it's going to tell us for any given set of prices and income exactly how much of x this person is going to choose. Okay, so once we've got our x star, the only thing we've got left to find is our y star. So we're going to do that in step 6 by substituting our x star that we found over here into the isolated y that we found earlier. We're going to simplify that, and that's going to get us to y star as a function of px, py, and m, which, similar to what we have with the x star, it's going to tell us for any given set of prices and income exactly how much y the consumer is going to want to choose. And so the very last thing that we want to do is to take the actual numbers for prices and income and plug those into our demand functions for x and y. And what that'll give us at that point are the actual final numbers of x and y the consumer is going to choose to make themselves as happy as possible. Okay, so that's going to conclude the first part of the video. If you have any general questions on the process, feel free to leave those in the comments below. And thank you for listening. Be sure to watch the next part where we do an actual practice problem on consumer optimization.